Let's try another example of a manometer problem. Here's my gas hooked up to a U-tube manometer. And let's say this container of gas is full of hydrogen gas. And the manometer looks like this. This is all full of mercury in there. And the right end is open to the atmosphere. And in this case, the atmospheric pressure is 0.962 atmospheres. And I want to figure out what is the pressure of the hydrogen. That's what I don't know. Well, I know the hydrogen gas is pushing down this way, and I know the air is pushing down this way. And let's assume the difference in heights between this height and this height happens to be 12 millimeters of mercury. Well, we want to figure out what is the pressure of the hydrogen. The first question I have is, which pressure is larger, the hydrogen or the air pressure? Well, in looking at the mercury here, hopefully you agree that the mercury is lower on the left side, which means the left side must have a greater pressure than the right side. So I know that the pressure of the hydrogen is greater than the pressure of the atmosphere. This number over here tells us how much greater. It's greater by 12 millimeters. So all I have to do is add 12 millimeters to the air pressure. However, my air pressure is in atmospheres, and these are in millimeters, and you can't add different units. So what I first need to do is take my 0.962 atmospheres and change that into millimeters. Well, 1 atmosphere of pressure is the same thing as 760 millimeters of mercury. So if you multiply your 0.962 times 760, you end up getting 731 millimeters of mercury. So this 0.962 is the same thing as 731 millimeters of mercury. I now can take my 731 millimeters, and since we said the pressure was larger than the air pressure by 12 millimeters, all I have to do is add those together, and we get 743 millimeters of mercury as the pressure of the hydrogen. So the pressure in the container would be 743 millimeters of mercury.